All right, hey guys, welcome back for week 5 of our ACT prep. Let's go ahead and restart our calculators. So second plus 712. So second plus 712. And then what's the other thing that we need to do after we do that? Yep, go to mode and make sure that you are back in degrees, okay? And I'm actually going to get out of this, and then we're going to start our problems, but just make sure that y'all reset that calculator, because we do have a couple of problems this week that if you don't reset it, you're going to end up getting negative numbers when you shouldn't get negative numbers, okay? All right, give this just a second. Okay, so this week we've got question 4, 21, 28, and 30. So let's go ahead and get started on question 4. Question 4 is isosceles logic. So basically what they're going to do with this problem is they're going to give you one angle, okay? They're not going to tell you which angle it is, so you need to decide, is it the vertex angle or is it a base angle, okay? So in this particular problem, they give us 92 degrees is the angle. So this has to be the vertex angle, because remember our base angles on isosceles triangles are always equal. So if I doubled that, I would end up with 184. Okay, 184 degrees. That's too many degrees for a triangle, right? How many degrees is in a triangle? 180. 180, yeah. So definitely can't be one of the base angles. It has to be the vertex angle. So first thing, go ahead and draw your triangle. Okay, hopefully you guys are getting good enough at these where you don't need to draw your triangle anymore, but draw them anyway. So remember, we've got our base angles on an isosceles triangle that are always equal. The one at the top is the vertex angle, and that's the one they give you, which is 92. Okay, so from there, you're going to take the 180 degrees that you guys told me were in every triangle, and you'll subtract out the 92 degrees. Okay, that leaves you with 88. Okay, how many angles do you have left besides the vertex? 2, right? So you have to divide the 88 by 2 to figure out what one angle is. So 88 divided by 2 is 44 degrees. Okay, so your answer for that one is J. We've done this question a bunch, you guys, so you should be pretty good at this isosceles logic, okay? Question 4, so it's earlier on in the ACT. It should be pretty easy, so this is one that you need to make sure that we're getting points for, okay? All right, let's do question 28. So this is a 4-sided figure, okay? It's an area problem. So based on the given figure, what is the area in square units of the parallelogram, okay? So the formula for this is area equals length times width, or you could say area equals base times height, okay? You could kind of say it either way. So for this particular one, it's not a rectangle, it's been skewed, which means it's just kind of been, it's got a different kind of angle on it, okay? So we need to figure out what is the height of this particular triangle over here so that we can go ahead and multiply the length times the width, okay? Does anybody remember, they're called Pythagorean triples, but there's a certain triangle that I've told you to remember. Do you guys remember what that is? Don't remember? 3, 4, 5. Do you remember it now? 3, 4, 5? Okay, so you have a Pythagorean triple called a 3, 4, 5. That is a right triangle, so this saves you time not having to do the Pythagorean theorem. If you don't know it, it's okay to do the Pythagorean theorem right here. But if you can remember 3, 4, 5, all you have to do from there is multiply each side by 2, and we've got this triangle, and we can get the height quickly, okay? So look, 5 times 2 is 10. 3 times 2 is 6. 4 times 2 would make this 8. Okay, so you can quickly get it. If you don't remember that, just do the Pythagorean theorem. So that's one of those formulas I told you to remember. So Pythagorean theorem is a squared plus b squared equals c squared. Okay, so we have the hypotenuse and we have one of the bases. So to find this 8, if you can't remember your Pythagorean triple, it is 10 squared by itself, because that's the hypotenuse. Okay, 6 squared plus x squared. I want you guys to put that in your numeric solver, okay? Can somebody tell me how to get to the numeric solver? Math, arrow up, enter. Okay, so math, arrow up, and then enter. Okay. And once you get that, do you hit enter to get your answer? No, what do you have to hit? Graph, or second, or alpha enter. We'll get it for you. Okay, did you guys get 8?
I have 7.9.
Okay, but you have to round that up. You got the 7.99999. So that is one thing that happens in the calculator sometimes, right? It'll give you the number and then it'll have a bunch of 9s behind it. You need to round it up, okay? And also, if you think about it, they're not going to give you something with 7.999 to try to calculate something else with, right? They're going to hopefully just have a whole number. Okay, so we found that this is 8 by doing the Pythagorean theorem, but you guys, this right here, if you can remember that one Pythagorean triple, it'll help you with some of these problems, okay? Because all we had to do was double everything, because that's the kind of nice thing about Pythagorean triples is they stay in proportion. So you can just keep multiplying them by whatever. I could multiply each one of those by 5 and find a whole new triangle, okay? But 3, 4, 5 is kind of the basic one that you want to remember, okay? Otherwise, just do the Pythagorean theorem. You guys know how to do that. Go to your numeric solver, find your answer, and then now this problem is super easy because even though these don't have right angles, it's still a 4-sided figure, right? So it's still length times width. So area of this is going to be area equals 18 times 8, which is 144. Okay. When you guys first looked at that, is that how you would have solved it? No. Yeah. When I first looked at it, it took me a minute too to figure out what I really needed to do. I honestly didn't at first think that I could just use the length times width, but after I would kind of work through it the long way, you can. It's just been skewed. It's still length times width, okay? Okay, you guys feel good about those two? Kind of good? Okay, let's go ahead and move on to a couple more. Okay. All right, question 21 is a circle. How many of you got to circles in geometry? Okay, that's good. Who did you guys have for geometry? You weren't here for geometry. Who'd you have?
Miss Whitley.
Miss Whitley, okay, and you had me, yeah. So circles are later on in the curriculum, so sometimes we barely get to it. But there's a couple of things that we need to know about question 21. So I'm just going to read it to you first, and then I'll give you a couple rules that apply to circles, okay? So the first thing is, I'll just read it. It's in the given figure, line AB, so that's right here, line AB, intersects the circle at points A and B, as shown. It's 12 centimeters long. If line AB, so this line, is 2 centimeters from the center of the circle C, what is the radius of the circle R to the nearest tenth of a centimeter? Okay? So first of all, AB is a chord. Okay, so that's a chord. I'll write that out here. Okay, there's a couple of different theorems that you need to understand. So the first one is that when you drop a line straight down to a chord, it's split in half. Okay, it's bisected, and that just means right in half. Okay, so if this thing is 12, this part of it is going to be 6. Okay. They told you that the center was 2 away. Okay, so we know that measurement. I told you that this is a bisector, but the other theorem that you need to know is it is a perpendicular bisector, which means that it makes a 90-degree angle right here. What can I use to find the third side of a triangle that's a right triangle? We just used it, Pythagorean theorem, yep. So listen, they just tested the Pythagorean theorem in 2 different problems in 2 different ways, right? It's important. You need to know that formula. So Pythagorean theorem to find our radius would be 2 squared plus 6 squared equals x squared. So remember, when we put it in our calculator, we always use x. Don't use any other variable besides x because you have that quick key that you can get to. So go to your numeric solver, math, arrow up, enter. Okay, go ahead and put that in, and let's find our x. And once you guys find it, let me know what you got. 6.3. Good. Okay, so even though you haven't gotten to circle problems, you guys, I know you guys have all done the Pythagorean theorem multiple times, right? So when you see a right triangle, you've got a couple sides, we need to be thinking about using the Pythagorean theorem to find that third side, okay? Okay. Everybody feel pretty good about this one? Yeah? So just, I want to reiterate a couple things though, because you probably will see something like this. This is a chord. The line that drops down from the center, up on this one, up from the center to hit that, cuts it directly in half. So they're going to give you the length of that chord, and then you need to cut it in half and only use half of it, okay? And then they also told you that this was 2 away. Makes a right angle, so you can use the Pythagorean theorem. Can you use the Pythagorean theorem on triangles that aren't right triangles? No, you cannot, okay? We would use something called law of sines and cosines for that, and that's later on in algebra 2, okay? Okay, let's do question 30. So question 30 says, a circle in the standard XY coordinate plane is tangent, no, underline that, tangent to the x-axis at point 30 and to the y-axis at point 03. Which of the following is the equation of the circle? Well, first of all, how many of you know the equation of a circle? We haven't even gotten to that yet, right, in algebra 2. So I'm going to write it up here, okay? So it's x minus h squared plus y minus k squared equals r squared. Okay. Guys, h and k, that's the center of your circle, okay? So I'm actually going to draw just a little bit of the coordinate plane, only the first quadrant, okay, because it's telling me I've got all positive numbers here, okay, so I'm not going to do any other ones. So here's my first quadrant. I'm going to try to do my best to, okay. Okay, so from here, it told me that on my x-axis, it was 30, so 30. On my y-axis, it's 03. Okay, so my circle is tangent to those 2 points. So the lines that are tangent form a 90-degree angle. That's what tangent means, okay? The line sits on the circle, and at that point, that line to the center forms a 90-degree angle. So I'm going to get my center of my circle first by just finding where these 2 points would intersect, okay? So if I come up here and then over from my y, I would put my center, and that center is 3, 3. My x coordinate is 3, my y coordinate is 3, okay? Then I'm going to find my radius. So my radius is just how many units I went from one axis to the center, okay? So it would be 1, 2, 3. So my radius is going to be 3. Okay? I'm going to draw just the outside of the circle, just sort of so you can see it. Not bad for a free-handed circle. Okay, so we've got our radius, and now we have our center. What do we need for our formula? Our center and our radius, okay? So let's go ahead and fill this equation in, okay? All right, so x minus my x coordinate is 3. And that has to be squared. Do you remember when I told you your x was a liar? Yeah. Yeah. It's fine. Or just, yeah. So the minus is part of the equation, okay? So if this was a negative number, you would say minus negative, okay? But it's not. Our center of our circle is positive. So you keep the minus and just put the 3. So when I tell you your x is a liar, it's not going in the negative direction like it says. It's actually going to be positive 3, okay? Okay, and then it has a plus in between. And then we have y minus, and then get your y coordinate of your center, which is also a positive 3. Square it. Equals, and then on the other side of the equal sign is going to be your radius, and we're going to square it. So my radius, we just counted up the units, 1, 2, 3, because that's how many places we went over on the x-axis, okay? I could also do it going the other way, you guys. Look, 1, 2, 3. If I counted up, I can still find my radius. So this will be 3 squared, okay? Now I want you to notice, it's obviously h or j, right? But h has minus signs because these were positive coordinates, okay? So you can't make them a positive. You actually need to make sure you're following the equation, okay? I do want to show you one place in your calculator you can do this, okay? So go to apps. Then you're going to hit conics. Okay, and the next thing should be circles. Okay, and then it's going to give you 2 different formats for the circle. Do you see the one that looks like this? Okay, make sure you pick that one. Okay, so go ahead and pick that. And then what's it ask you for? H, K, and R. So H is your x coordinate of your center, K is your y coordinate of your center, and then R is your radius. If you enter those in, this will show you your equation, okay? So again, apps, I'm gonna write it over here. So if you go to apps, move this, move that guy down, conics, and then make sure you look for the format of what your answers look like. If your answers don't look like this and they look like the other one, pick the second one, okay? But most of the time we're talking equation of a circle, it'll look like this. So pick that first option, put in your center, your H and your K, and then put your radius in, and then do you hit graph or enter? Which one worked? Graph worked? Okay, and what did you guys get? Did you get H or J? Which one was the right equation? What's your calculator say? H, yeah, H. So if you can remember to go to that, first of all, you gotta be able to pick out what the center is, right? But look, you guys, they told you the center, okay? And then from there, you just count over to find your radius, and then you can actually enter this into the calculator and it'll tell you your equation, or this is not a bad formula to have memorized, okay? Just so that you can throw the things in and get the right answer pretty quick, okay? I think there's one other one. Let's just make sure that there's not another one down here. Nope, that's it. Okay, so just those. So does anybody have any other questions about those? Okay, we do have our extra practice, so it's behind. I'm gonna go ahead and do one of each of those with you, okay? So let me pull that up.
One more question, Brian.
Do what? There is, I thought there was one more. 42? So you guys have one more question on there, right? Okay. I thought there was another question. Let's see. Tell you what we'll do. Because I do not see it there. Let's see. Oh, there it is. I just didn't move up far enough. Okay, let's finish this and then and then we'll do the extra, okay? Sorry about that, y'all. Okay, so question 43. A right circular cylinder. So we should draw that, okay? So a right circular cylinder. That's my best version of a right circular cylinder. You guys, there are other things besides right circular cylinders, okay? You'll see some that are skewed, but they're actually gonna tell you right circular cylinder, okay? And since it says the word circle and we're looking at our answers and we see pi, this is a volume question. So it says a right circular cylinder has a base diameter. So the diameter is 20. Okay, the diameter goes all the way across your circle, okay? We're not gonna need our diameter, we're gonna need the radius. So the very first thing I'm gonna do is put R equals half of that, which is 10, because I know I'm not gonna end up using the diameter. The only thing that uses diameter is the circumference of a circle, and that's not what they're asking us for here. I am gonna need the formula, and you guys, this is a formula you need to memorize, okay? So volume equals pi R squared, okay, times the height. They told us the height is 2, okay, and so all I'm gonna do is I'm gonna enter this into the calculator. And the one thing that you need to notice is since pi is left inside the equation, we're not gonna stick pi in our calculator, okay? We're just gonna write it behind once we find our answer. So let's go ahead and put all these in. So you've got volume equals pi. My radius is half of my diameter, so 10 squared. And then my height is 2. So the part you want to put in your calculator is just this part. Okay, so go ahead and put 10 squared times 2. And you'll see that your answer is 200 pi. Okay. Now, if you put the pi in, it's going to multiply out 3.14, blah, 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 right? So we don't want to do that. We just want to do the 10 squared times 2 and put the pi behind it, okay? So this is a formula you need to know. Okay, the other thing I would tell you is the volume of a sphere. That's one that you probably should know too, okay? So volume of a right cylinder, volume of a sphere, volume of a four-sided figure. Okay, those 3 volumes are probably things you need to know, okay? All right, now that we've done the last problem, let's do those extra problems, okay? Okay, so we'll just do the version 1. Remember, each week I give you 5 new versions of the same problems just so you can practice them, okay? So one thing to note on these is it did not give you any shapes or anything. So if you need a circle, you'll need to draw the circle so that you can see what it looks like. But honestly, I think that's good practice because then you'll know, like, I need to draw the circle with the chord and all of that good stuff, okay? So question 4. One of the angles of an isosceles triangle is 100 degrees. What is the measure of one of the other angles in the triangle? Okay, isosceles tells me that 2 sides are equal and 2 base angles are equal. And because this is a 100-degree angle, I know this has to be the vertex angle because 100 times 2 would be 200. That's too many degrees for a triangle. So this is just going to be 180 minus 100, which is 80. Okay, and how many angles do we have left over? 2, so we divide by 2. 80 divided by 2 is 40 degrees. And so this would be J. All right, question 28. In a parallelogram ABCD, the slant side, okay, so I'm going to go ahead and draw it with the slant. Okay, so A, B, C, D. And guys, that's one thing that I've kind of noticed in class that we've just been doing a little, like kind of putting letters wherever we want, and they can't be like that. You actually have to go around in order. So like you can't do A, B, C, D. It has to be A, B, C, D. And I did A down here because they told me that that was one of the slant sides. So I just labeled my slant A, B, okay? All right, so AB is 13. Okay, a vertical height line is dropped down, okay, from B to the base AD, which creates a small right triangle that has a base of 5. Okay, this is one of those other Pythagorean triples. It's not quite as common as the 3, 4, 5. So I would do the Pythagorean theorem here for this one, okay? So let's do the Pythagorean theorem. Remember, we've been given the hypotenuse, so that goes by itself. So this will be 13 squared equals 5 squared plus x squared. Okay, and go ahead and put that in your numeric solver. So math, arrow up, enter. And remember, we hit graph, graph to get our answer. So once you find x, let me know what it is.
So
12, good. So this is a triple also. Sure the heck hope I spelled triple right, you guys. I'm a math teacher. Sometimes spelling doesn't look right to me. Okay, so 5, 12, 13 is also another Pythagorean triple that I would remember if you can, okay? Because hopefully that's what they'll use for all of these and you can save yourself some time, but that didn't take you guys much time at all to find it, right? So this is gonna be 12. Okay, they told us that BC is 20. And so now all you do is 12 times 20 and get your answer, okay? And once you get it, let me know what it is. 240, good. Good, good, good. All right. Question 21. So in a circle with center C, so this is what I'm talking about. You're gonna have to draw this, okay? So let's just draw a circle with center C, okay? A chord AB. So a chord AB is 16 long, okay? I'm not gonna label it just yet. If the chord is 6 centimeters from the center, I should have put my C somewhere else. So it's 6 centimeters from the center of the circle. What is the radius? Okay, what is the radius? And the radius just goes from the center to anywhere on the outside, okay? But we're gonna connect it down to A so that we can make this right triangle, because that line that drops from the center and hits our chord is always perpendicular and it bisects, it cuts it in half. So now we have this, and then we're gonna take 16 and divide it in half, because this whole chord is 16, which makes just the part of my triangle 8. And then we'll do the Pythagorean theorem to figure out what our R is. So this is gonna be 8 squared plus 6 squared equals x squared. And once you figure out what it is, let me know what you found. 10? All right. So the question's answer is A, 10. Okay. Now, you guys, it's asking to the nearest tenth. You have to remember that the tenth is just one decimal. Okay, one decimal. But the last one worked out to where it was the exact answer that came out, and so did this one. So hopefully that's sort of how it'll work out. But just remember, the tenth is just one decimal place, okay? How do you guys feel about these three so far? Pretty decent, but the Pythagorean theorem is there a couple of times, right? Just in today's stuff. So, and I know we've used it a few other times. So that is definitely something you need to make sure that you understand, okay? All right, I'm gonna hit my X and then I'll scroll up and we'll do 2 more together, okay? All right, last couple. Okay, so we've got this same kind of question again about the axis system being a tangent point. And actually, so the points are tangent, or points that are on the edge of the circle, but really the axis lines are the tangent lines, okay? So this says a circle in the standard XY coordinate plane is tangent to the x-axis at point 40 and the y-axis at point 04. Which of the following is the equation of the circle? So I'm gonna draw it again just to show you. So here's my first quadrant, because that's all I need. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so it said at 40 and then 04. Okay, so my center is going to be right where these two would meet, so that's going to be 4, 4. And then I just count over to figure out what my radius is. 1, 2, 3, 4. So my radius is 4. And I'll try to draw a circle. There we go. Okay, so but now that I have that, I can go to my calculator, do you guys want to go to the app? Let's try the app and then we'll write it into the equation, okay? So go to apps, conics. So apps, conics. Okay, and then you'll pick the format that looks like it. There's two different formats sitting in there. Squared equals 4 squared, okay? And if you notice, be real careful over here. Sometimes they go ahead and they actually multiply the 4s by each other and you get 16, right? And I think last time we got a 9, but it could be written like this. Okay, so either way, you need to just make sure that you're kind of looking at the radius part of this, which is after the equal sign. Okay, so which one of these is correct?
G.
G, good.
Mom, I have a question.
Yeah.
For the radius, like, when you be doing the work,
So look, that's kind of confusing you, the counting. Okay, so when you're on your graph, you just count over each unit, right? So that's all I did. So on your x-axis, 1, 2, 3, 4, and that gets me to my center, right? But you could also count up too. So 1, 2, 3, 4, and that gets me to my center. So that's all you're doing is just counting the, yeah, no, I'm not just willy-nilly counting. It's literally just counting the units over to the point they gave you because that's midway, okay? And then you can get your radius, all right? Okay, last one, you guys, and this will be our last practice problem too. So question 43, which is later on in the ACT that they think is a little bit more difficult, but if you remember this formula, you guys are gonna get all of these right, okay? So a right circular cylinder, I'm gonna draw it again. Okay, right circular cylinder has a base diameter. Okay, again, they're giving us the whole length, base diameter of 10. We only need half of that, so R equals 5. And the height is 5. Okay, so we'll write that in. What is the volume of the cylinder? So again, that formula is volume equals pi R squared times H. Pi is in our answers, so we're not going to put pi in the calculator. So you're just going to fill in your formula. So volume equals pi. My radius is half of the diameter, so 5 squared times 5. And all you're entering in your calculator is just that part. Don't put in the pi. Okay, once you figure it out, let me know. 125. Because 5 times 5 is 25. Times 5 is 125. Okay? All right, you guys, how do y'all feel about that? Pretty okay? Okay. So for those of you that are out kind of watching, please make sure you're practicing with your online calculator, okay? So that you can get good at it. The more you practice it, the better you're gonna get. If you don't touch it until the test, you're not gonna do well because you're just not gonna know what to do, okay? So please make sure you're practicing. If you need help, come by my room. I have no problem helping you guys, okay? I would rather you come here and get some help before the test. And one other thing I just want to tell you guys, some of my kids that have been sitting in my class working on these ACTs have actually taken practice tests and they've already improved their scores. So like we took half of an ACT the other day with 26 problems and I had several students get 21 problems right out of 26 on a test they had never seen before. So please just keep practicing, okay? You're gonna get better. We have about a month. So today's the 10th. Of February, we take this test on March 10th. So we have 30 days, okay? You guys can do this. I know you can. I believe in you, and I want you to keep trying, okay? Because I think we're all gonna be shocked once we get those scores back in May. All right, thanks for joining, guys. I appreciate you.